Determine which postulate, if any, can be used to prove that the triangles are congruent. So remember, when we're doing these, we want to make sure that we mark up the triangles with whatever information we know already. For instance, as we look at example 1a, the one thing that we know is that this side length is in this triangle, and it's also in this triangle. So it's a part of both. So when we look at this, what we've got is we've got a side, and then we've got the right angle, and then another side. Notice that that angle is included. I did the 2 tick marks first, so here's the 2 tick marks, side, angle, side, abbreviated SAS. Again, mark up the triangles. And once again, what we see is that this side is in this triangle as well as in this triangle. And because it's in both, well, sorry, I need to mark it. But now what we have is we have a triangle with 1 tick mark, a triangle with 2 tick marks, triangle side, and a triangle side with 3 tick marks. We have that same situation, 1 tick mark, 2 tick marks, 3 tick marks. So we can say that this one is congruent by side, side, side. Once again, the same idea. In fact, on all 4 of these in example 1 or problem number 1, we've got this included side that's part of both. But if you look at this particular triangle here, we've got a side and a side, but this angle is not in between the 2 sides. It's not an included angle, so we cannot say that these 2 are congruent. Same idea happens in letter D. Once again, we've got this, but on here we've got this side, an included angle, and this side. But then when we compare it over here, we've got this side, still starting with the 2 tick marks, but we would have to have this angle here, the included angle, and this for them to be congruent. So this is also not congruent. Gotta spell it right.